describe the scientific method and informs the scientific process. The scientific method is a systematic approach to discovering new knowledge about the natural world. It is a process that involves making observations, asking questions, formulating hypotheses, testing those hypotheses through experiments, and drawing conclusions based on the results of those experiments. Here is a brief overview of the steps involved in the scientific method. Observation. Scientists observe and gather information about a phenomenon or event in the natural world. Question. Based on their observations, scientists ask questions and formulate hypotheses to explain what they have observed. Hypothesis. A hypothesis is a tentative explanation that can be tested through experiments. It is a statement that can be falsified or supported by the results of experiments. Prediction. A prediction is a statement that describes what is expected to happen if a hypothesis is true. Predictions can be used to design experiments that test the hypothesis. Experiment. An experiment is designed to test the hypothesis by manipulating one or more variables and observing the effects on the outcome. Experiments are designed to be controlled and repeatable, with the goal of minimizing the effects of extraneous variables. Results. The results of the experiment are analyzed to determine if they support or contradict the hypothesis. If the hypothesis is supported, the results can be used to draw conclusions and make new predictions. If the hypothesis is contradicted, the scientist may need to revise the hypothesis or formulate a new one. Conclusion. Based on the results of the experiment, the scientist draws conclusions about the hypothesis and the phenomenon being studied. These conclusions can lead to new questions and hypotheses, which can be tested through further experiments. The scientific method informs the scientific process by providing a framework for generating new knowledge about the natural world. It allows scientists to test their ideas and theories through experiments, and to refine those ideas based on the results of those experiments. The scientific method also encourages scientists to be skeptical and objective, to base their conclusions on evidence rather than personal beliefs or biases, and to communicate their findings clearly and openly to the scientific community. Overall, the scientific method is a powerful tool for advancing our understanding of the world around us and for making new discoveries that benefit society. Differentiate among hypotheses, theories, and laws. Hypotheses, theories, and laws are all scientific concepts, but they refer to different types of scientific explanations that have varying levels of certainty and support. Hypotheses. A hypothesis is a tentative explanation for a phenomenon that can be tested through experiments or observations. It is an idea that has not yet been proven or disproven, and it often serves as a starting point for scientific inquiry. Hypotheses can be developed through observations, logical reasoning, or previous research. A hypothesis that has been tested and supported by evidence may eventually become a theory. Theories. A theory is a well-supported explanation for a broad range of observations and phenomena that has been repeatedly tested and confirmed through experimentation and observation. Theories are typically supported by a large body of evidence from various sources, and they can be used to make predictions about new phenomena. Theories are not absolute truths, but they are considered to be the most reliable and accurate explanations we have for natural phenomena. Examples of well-established scientific theories include the theory of evolution and the theory of relativity. Laws. A law is a statement that describes a fundamental relationship between observable phenomena that has been repeatedly observed and verified. Laws do not explain why phenomena occur, but they describe how they occur. Laws are often expressed mathematically and can be used to make predictions about future observations. Examples of scientific laws include the laws of thermodynamics and the law of gravity. In summary, hypotheses are tentative explanations that have yet to be supported by evidence. Theories are well-supported explanations for a broad range of observations. And laws are descriptions of fundamental relationships between observable phenomena that have been repeatedly verified. Hypotheses can become theories if they are supported by evidence, and theories can become laws if they describe a fundamental relationship between phenomena that has been repeatedly observed and verified.